Alright, so we left off talking about how to find protons, neutrons, and electrons in an ion. So here I've just made a table where I've listed some common ions and I've found their number of electrons just like I would last week. So if you're not quite sure how I found these, just review last week's material and you'll see. Now, there's something I wanted you to see here. There's a pattern I wanted you to see here, so that's why I made a big list. If you look at the number of electrons, right, there's a 2, a couple 18s, a couple 36s, and a couple 10s. And actually, there are some magic numbers when it comes to electrons. So what that is 2, 10, 18, and 36. And technically, I mean, it keeps going. 54 is next, but you don't really need to. 86 would be next, but really these first four are gonna take care of it. So for our purposes, what this means is atoms want to have this number of electrons. They want either 2, 10, 18, 36, or 54 electrons. It makes them happy. Why does it make them happy? Because it completes their shell. So if we look at a periodic table, you'll see helium is number 2, neon is number 10, argon is number 18, krypton is 36, and xenon is 54. And yes, radon is 86 as well. So it's because these guys, helium, neon, argon, krypton, xenon, radon, the noble gases, these are the cool kids, all right? That is the cool kids club. Everybody is trying to have the same electrons as those guys. Obviously, they're not actually trying. They're not actually thinking. It's just the way it is. But it's just forces. But the idea is, what happens is every time you go down a row in the periodic table, you open a new shell, right? So if we go back to talking about our model of the atom, where we have our positive nucleus and then we have our electrons around the outside, right? So having just one ring would mean you're just in the first row, you're hydrogen or helium. Then if you want to move down to lithium, you add another ring, right? Go across. Go to sodium, you add another ring, so on and so forth. And electrons want those rings to be totally full. So atoms want those rings to be totally full. So what these guys do is they either gain or lose electrons in order to have their outer shell totally full, right? So for instance, this is, let's see, we're 1, 2, 3, we're the third row down. So let's make this just sodium. Third row down, 1 electron. This is sodium. So sodium wants a full outer ring. So it has two options. It can either remove just one, and now this, which is totally full, will, and I'm going to try to talk and draw this at the same time, which will be a challenge. There it is. Right, this inner one is totally full. So if it just gets rid of this electron and closes this outer ring, its new outer ring is now full. Yay, that's a win. Or it can gain 7 more electrons. That's a lot of work. That's why sodium always has a positive 1 charge, because it's a lot easier, right? It has 11 electrons, so it's sitting here at 11, and it has to choose, all right, I'm at 11, what's easier, getting to 10 or getting to 18? It's a lot easier getting to 10. So actually, all of those elements in that first column, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, all of them only have 1 electron in that outer shell. So all of them are trying to lose 1 electron. So all of them have a positive 1 ionic charge. So that's actually part of one of the million things that are great about the periodic table, is as you go down a column, they have very similar properties, right? Sodium, lithium, potassium have very similar properties, right? Because they're all in the same column. Okay, so right as we go here, nitrogen, right? Nitrogen is number 7. That means it normally has 7 electrons. So let me give you, right? So here's nitrogen, with its 7 electrons. 1, 2, 3, 4, 5, 6, 7. It's 2 in the middle, and then it has 5 on the outside. So again, it has 7, so it has to choose, do I go to 2 or do I go to 10? Well, for nitrogen, it's easier to go to 10, because that's only 3 away, whereas going down to 2 would be 5 away. So it's going to want to pick up 3 electrons. And again, everything in nitrogen's column is going to want to pick up 3 electrons to get to either 10, 18, 36, whatever, whatever the next one is. So that's why nitrogen has a -3 charge, because it is going to gain 3 electrons. Electrons are negatively charged, so that's how it works. So if we look at the periodic table, everything in this column has a +1 ionic charge, because they all want to lose 1 electron to come this way. These all have a +2 charge, because they want to lose 2. These, basically aluminum, but this has a +3, because it's going to lose 1, 2, 3. Carbon's column isn't really a part of this. It doesn't really do the ionic thing, so we're going to skip that for now. And then if we come back over here, this column, these all need to gain 1 electron to have the same electrons as these guys. These all need to gain 2, and these all need to gain 3. So these would have the ionic charge of -1, the ionic charge of -2, and the ionic charge of -3. So it would be great if you could comprehensively, just deeply understand why these have the charges they have. That would be awesome. If you need a little more time and you're still struggling and need to ask some questions and get some help, totally understandable, that's fine. What you should do is just write these, +1, +2, +3, -1, -2, -3, at the top of your periodic table. So now from now on, if I ask you, what's the charge of oxygen? You can look at it, find it, and know that it's a -2, right? What's the charge of aluminum? Find it, know that it's a +3. What's the charge of strontium? Find it, know that it's a +2. So, if you need to rewind this and listen to the reasoning or ask some questions or whatever you need to do to understand it, I'm here for you. But really, writing these down on the top and being able to find them is really step 1 in being able to do the next thing. Okay, so for the next part of this, we have to figure out how to put ionic compounds together. What that means is how to make their charges balance out. So again, if we recall, sodium, if you look at sodium on the periodic table, it's on the left, it will have an ionic charge of +1. So an important thing here is sodium by itself sitting around does not have a charge of +1. All of those things don't always have the charges, because if they did, then everything would be, electromagnetic forces, and it would be craziness. This is only their charge when they combine ionically, meaning sodium wants to get a +1 charge, right? When we talk about chlorine, chlorine wants to get a -1 charge. Normally, chlorine sitting around doesn't have a -1 charge, but it's trying to get there, right? So remember, sodium wants to get a +1 charge, which means it wants to lose an electron. The +1 charge means it's losing an electron. Chlorine wants to gain an electron. So that's why these guys are like a match made in heaven, right? Sodium is looking to get rid of an electron, chlorine is looking to gain an electron. So what we have here is an ionic bond, which is when one atom takes an electron from another atom. And that's what this is, okay? So they happen to, this is a +1, this is a -1, it works out, everybody's happy. Okay, we're going to do a million examples. Okay, we're going to do like 5 examples. You'll see that's not always the case. So, the other thing I should mention is this, when it's just Na, just sodium, okay, this is called sodium. When Na has a charge, it's also called sodium. Chlorine, when it doesn't have a charge, when it's by itself, is called chlorine. Chlorine, when it has that ionic charge, is now called chloride. So then if a thing gets a negative charge, we put an "ide" at the end of it. So this is sodium and chlorine. This is sodium and chloride. All right, let's do a few more examples. So, for instance, calcium and chloride combining. So we look at our periodic table and we see chloride is a -1 and calcium is a +2, right? What this means is calcium is trying to get rid of 2 electrons, but chloride is only trying to pick up 1 electron. So this doesn't balance out, right? A +2 and a -1 don't balance out. We're trying to get the charges to equal 0, to sum to 0. So this doesn't work. But if I have 2 chlorides, right? Now I have 2 chlorides. So when calcium is trying to get rid of those 2 electrons, it can give 1 to each chloride, and everybody's happy. And then 2 -1s gives us a -2, which will cancel the +2. So this is how calcium and chloride would go together, right? We could, same idea, we could talk about aluminum and fluoride, right? Again, aluminum being a +3, fluoride being a -1, doesn't work. But if you have 3 fluoride, now 3 times -1 is -3, so those will cancel out. All right, let's just keep doing examples. All right, what if I have sodium and oxide? Again, find it on the periodic table. Sodium is a +1. Oxygen is a -2. They're not going to cancel that way. But if we have 2 sodium, the 2 +1s will cancel that -2. Right? So this is all we're doing. Now, there is kind of like a cheat code to this. The cheat code is just that you always have the absolute value of this many here and the absolute value of this many here. Right? This is kind of the way to cheat. There is only one problem with that, which I'll show you in a minute. Right? So this is about as hard as it gets right here. If I want to combine aluminum and sulfide, you look at your periodic table. Aluminum is a +3, sulfide is a -2. A little tricky, right? If you do 2 of these, well, now this is a -4, it doesn't cancel, so okay, fine, let's do 2 of these. Well, now it's a 6 and a 4, those don't cancel. So you have to think about what is the least common multiple. What can we turn them both into, a 3 and a 2, both into, so they will cancel? A 6. So if I have 3 sulfide and 2 aluminum, I'm going to have 2 3s, which is 6, and 3 -2s, which is -6, and they'll cancel out. But of course, the kind of like cheating way to do it is just like this. Now, the couple times that doesn't work so great is if we have something like magnesium and oxide, right? You get on the periodic table, magnesium has a +2, oxide has a -2. So they cancel each other out, just like that. You're done. You don't need anything. But sometimes people want to take the 2s and put them on there. If you ever get yourself to a point where you have a formula and it can be reduced, right? You can divide them both by the same thing, then do it, right? If you ever get a situation, oh look, they can both be divided by 2, let's divide them both by 2, and that's what we get, right? If you ever, work yourself into some situation that's, I don't know, I'm just going to make this up, it's like x4, right? Something 4, something 8. Don't leave it like that. When we're doing this, this is totally correct later in chemistry for other things. But for this, you always want to reduce it down, right? So you would reduce that down just to x, y2. Right? Because you can divide them both by 4. And that is how you combine ionic compounds, so their charges cancel out.